With factoring polynomials when a is 1, so that when we go beyond a equals 1, things don't get quite as weird. It will get weird. Okay? It will. We're going to try to learn that today. Okay? We're going to derive that, like come up with it ourselves, the way things will work. What's going on? All right. So 5. So we know that if we want to factor a polynomial, before I get into it, I guess we should do this, right? Let's do an example like this, okay? We know if we have something like this, right? Right? Working backwards, guys. Oh yeah, by the way, Logan, switch with Olivia. Actually, hold on.
Not switch Logan with Mitchell. Me and Mitchell are dogs. Or Jace.
Olivia and Jordan switch, and then Jordan switch with you. So Jordan, what's going to happen is you're going to end up being here, and Olivia is going to end up being here, and you're going to be next to Olivia here. So Olivia move over 1, you move over 2, and then you move over all the way. Try that. Wait. Try it. Yeah, try it. Try that. Yes. Does that make sense?
Why doesn't Logan just sit back here? Or why doesn't he just sit in the front?
I think it'll make more
Can I sit right next to you?
Him and Lindsay can stand.
No. Shut up. Why are the desks over so far?
I don't know.
Okay. This is proper row. This is good. I'm going to move this over and put this behind here.
Get over here,
Fall in line.
All
Right. Fall in line that way. These are way
Yippee!
Like the point was, if no more as possible and give space for the closets, we have slowly decided not to. There, go. Cool. Shamba, sit next to Logan.
What? Hey! He's not going to like it now, and then he's going to switch it. We're going to change. We're going to see you all the way.
Can't open
And
this
then
here.
Ann, switch with Mitchell. Switch with Mitchell.
No. Whoa. Whoa.
Actually, no. What I meant was you two move over 2, you move over 1. So Mitchell, you're going to be here, you two move over 2.
Mitchell's his dog. At least you remember away from your brother.
Yeah. Me and Jason right here.
I don't think Jace wants to.
What? We were the same.
I think that's what's wrong.
CJ's still here.
Yeah.
I feel like I'd work a lot better
And then-
if I was next to a wall.
Josh,
Switch
you
with
sit
me.
there. No, Josh, sit behind me.
Sit by who?
Wait, is that where CJ sits? That's right.
Yeah, that's what CJ
Sit behind there. Stay there. Nope, CJ's good. CJ's good.
And then I sit on the wall.
CJ.
No. CJ's good. She's good. Josh, move back. I forgot that she's there. You're not sitting behind Michael. All right.
CJ just moved it.
Today. Let's go.
Come on, Buttercup.
All right. When you guys are all ready, we'll get started on this. So,
I'm not ready yet.
working in reverse. This is what we did yesterday, right? We know that this is going to become x squared, right? Plus, sorry, not plus. Minus 2x minus 15. Why is that? X and x makes x squared, right? X and minus 5 makes minus 5x. What's this going to make? 3x. Minus 5x plus 3x minus 2x, right? And then 3 and negative 5 makes minus 15. We cool with that? Okay. So let's generalize this. Right? X squared plus ax plus bx plus ab, yeah? You cool with that? What?
Did me and Josh switch? I feel like
No. Shut up. All right. So these guys right here. No. Wait, what's up?
Is this number? Are we doing number?
We're not doing any number right now. Okay. Bring you back in. All right. Here and now, right? So whatever goes here, if we're working backwards, right? If we're going from this to here, right? If we want to take something like this and move to there, A and B, whatever those numbers are, they're going to add together to whatever this guy is, right? Does that make sense? Right? So whatever goes here, those numbers have to add to it. Does that make sense? And then whatever goes here, those numbers have to multiply to it. Do we see that? So if we have an equation, let's get rid of the a. A is 1, right? If we have an equation, when we factor this out, whatever we get here and here is going to add to this, right? And it's going to multiply to this. Are we cool with that? We add to this guy, multiply to that guy. We fine with that? That's why. So, when you look at number 5, we need numbers that go here and here that add to negative 10, right? It adds to the middle term, right? Those guys add to make the middle guy, right? And the outside number, we need numbers here that multiply to make that, right? The two regular numbers multiply to make this guy, right? Then we get something x plus something x equals this guy, right? We add these guys. We cool with that? Okay. So we need numbers that add to negative 10 and multiply to 9. Now, list me all the numbers that add to negative 10. Whole numbers. We'll limit to whole numbers, no fractions. 1, 9, 2, and 8, 12 and minus 2, right? Infinitely many. So I don't want to list those. List me all the whole numbers that multiply to 9.
1 and 9.
1 and 9, 3 and 3, right? So our options are 1, 3, 9, or negative 1, negative 3, and negative 9, right? Like double negative gets us a positive, right? So those are our options. Much fewer options. So we want numbers that multiply to positive 9. We got them, right?
Yeah.
Which ones are going to add to negative 10?
But 1 is a 9 or the negative.
But the negative versions of them, right?
Yeah.
Negative 1 and negative 9 add to negative 10, right? So that's going to be our factorization. You guys with me?
Yes.
We don't have a
Logan?
Yeah.
You here?
I was wondering who was behind me.
I know it's minus because negative 1 times negative 9 does get me 9, right? But it also adds to negative 10. It fits both criteria. So we figure out, girls, so we split it up based on what we need to multiply to because there's fewer of those, right? There's not infinitely many of them. And then we choose which ones we need that add to this guy. How do we feel? Right?
Negative.
Okay. So for this one, we want numbers that multiply to 64. That's a lot of numbers, but at least it's not infinite, right? And they add to 16. So what numbers multiply to 64? Well, 1 and 64, 2 and 32. 3 go into 64? No. 4 does. 4 and 16. And then 8 and 8, right? Now, couldn't it also be double negatives, right? Negative 1 and negative 64, right? So I'm going to wrap these all in parentheses and just know if you go with positive, excellent, go with positive. If you go with negative, go with negative. I'm just making notes. You can do it however you want, okay? You can write out all the other ones. I don't care. Now, we want ones that add to 16. Question, will double negatives ever add to 16? Like two negative numbers add to a positive number? No way, right? So we don't care about the negatives. We know it's got to be positive. So which ones add to 16? 8 and 8. And 8 and 8 do get 64 when you multiply, right? As it turns out, isn't there a simpler way I could write this?
Yeah, you could.
I'm sorry, it's B. I'm sorry. Okay, I'm sorry. I am, sincerely. I am. Isn't this the same thing as this?
No.
Something times itself, right? So it turns out this was a perfect square all along. No. Was this a perfect square? No, it wasn't. We'd have to add something to get the perfect square and then find vertex form, right? This one is already a perfect square. Right? The dimensions of that square would be 8x plus 8 by x plus 8. The dimensions of this guy would be x minus 1 by x minus 9. That's a rectangle, right? Cool? That's it. You want to see another one?
Yeah. Let's do number 7.
Let's do 8.
So.
Let's do 9.
Yeah, let's do
Yeah.
Numbers that add to the middle guy and multiply to the last guy, right? So factors of 40. 1, 2 goes into it? Does 3 go into it? 4 does. Does 5? Does 6? Does 7?
Yes.
No. Does 8?
Yes.
Yes. Now, just so we know, 1 goes with 40, right? And 2 goes with 20. And 4 goes with what?
8.
10.
Oh.
And 8 goes with 5. So we're done, right? Do you see how I only had to check up to 8? And I knew that because the root of 40 is approximately what? What's the root of 49? 7. So I need to check up to about 6. Right? To about 6. In this case, I needed to check 8. Cool. So, these are our options. Now, we can either do double positive to get a positive number, right? Or double negative, right? But here's the thing. Will a double positive ever add to a negative?
Yes.
2 positive numbers add to a negative? No. They could both be negative, right? Right. Now you could do a positive and a negative number, just have the negative number be bigger, but that wouldn't get a positive answer when you multiply, right? So double negative is what we got to deal with. So it's got to be x minus something and x minus something, or k. K.
Wow. So aggressive.
What numbers add to 13?
5 and
5 and 8. 5.
And do they also multiply to 40? They do. Double check that, because a lot of you guys would be like, oh, I need something that adds to 3. Oh, 1 and 2 add to 3. But do they multiply to 4? They don't go together, right? Yeah, just be careful, right? And not all of these will come out nicely, right? That's why we need the quadratic formula, right? These are just nice ones. They're factorable, is what we say.
Is this supposed to be the answer?
If it's not factorable, you use quadratic formula and you get a weird root thing and you call it a day.
Is this the answer?
So that's a factorable equation. Most equations that you make up won't be factorable, right? It happened that these guys coincided, right? Like, what if that was a 15? Are there numbers here that add to 15? No.
It said 10 and 5.
Oh, 10 and 5, but do they also multiply to 40? No, they don't. Remember, it's got to come in pairs. So if that was a 15, would it be factorable? No. What would it be if it was 15? Well, great question. If we have, I'm switching it to x. Why did I write a? A squared, thank you. I am. I'm going to be here super late tonight helping kids. So if you need help after practice, I will be here. Don't be afraid to stop by.
What time will you be here?
At least until 6.
Oh, that's what I'm right.
So, not factorable. How do I know? What are the factors of 40? Do any of those add to 10 and multiply to 40? No, those add to 10, but they don't multiply to 40, right? They got to be in pairs. So it's not factorable. So what do we do in this situation? Well, A is 1. B is what?
2. 15.
C is quadratic formula, right? Right? So let's do that. Let's practice. So opposite of B is what?
C. Oh, -1.
Negative 15 plus or minus B squared. What's 15 squared? You can do it. 15 times 15, right? I know 15 times 10.
125.
What's 15 times 5? Well, 50 plus 25, which is? So 15 times 15 must be
1 times 10.
what? 225. Right? Okay. It's okay. I know it's the end of the day,
Or 10 times 10.
but if it weren't the end of the day, you could do it. What's A? What's C?
6.
Our favorite A, right? And C is 40. All over what?
Quality poverty ratio.
Not 4A,
This is
2A.
2A, double A, yep. Which will be 2 in this case, right? So, 225 minus whatever this is. What's 4 times 40?
It's 160.
160. What's 225 minus 160?
1.
Count on up. 160 plus 40 gets me to 200, right? Add 25. So I went 40 and 25. It's 65, right? Can I simplify that? Let's find out.
Yes.
Is 65 reducible?
Yes.
5 and what goes into 65?
8. No. 12.
13.
13, right? Because 12 gets me 60. Can I break down 5? No. Can I break down 13?
No.
So 5 times 13 in the jail. Does anybody get out? Nope. Simple as it gets. Can I divide 15 by 2?
No.
No. So leave it alone. That's the answer. So our answer would be x plus, this is going to be weird, negative 15 plus root 65 over 2, right?
Why do you have the bracket?
And then x minus, I'm sorry, plus negative 15 minus root 65 over 2. Okay? You don't really need those brackets. You could just do x minus 15. You could just do x plus negative 15 plus root 65 over 2. And you could do x plus negative 15 minus root 65 over 2. Hey, it's just kind of weird because I have a plus and a minus sign there, right? That would be the factorization. Would you be able to come up with that on top of your head? No. So we call it not factorable, right? And that makes sense because when you list the factors of a number, do you ever get like fractions or anything? No, you get whole numbers, right? So those aren't whole numbers. We say it's not factorable. Just like how 3 is not factorable beyond 3 and 1, right? It's prime. So in some sense, this is like a prime polynomial, right? Yeah.
So like one of these problems like doesn't work, we just use what we learned last.
Yeah. Now, what if it does work, but you can't find the solution, right? Couldn't you do quadratic formula for this?
Yeah.
You could, and you'll get nice answers. You'll get 5, minus 5, and minus 8. Right. That's it. Yeah. All of this craziness, right, will simplify to minus 5 and minus 8. It'll be like, it'll probably be like 6.5 minus 1.5, and then 6.5 plus 1.5, right? Plus or minus thing, right? It'll get you, right? That's it. Now, the question is, what happens when A isn't 1? Right? Ladies and gentlemen, now we're going to explore something more difficult. What happens when A isn't 1?
Point.
Big bomb.
Let's work backwards, right? What will this become? X squared. We get a minus 3x and a plus 2x, so we get minus 1x. And then minus 6. Is A 1 here? It is. If I change these numbers, will A ever be more than 1? No. So there must be something else we need to change. Something with the x, right? What if this were a 2? We would get 2x squared, right? What would we get here? 4x minus 3x is. And then we still get the minus 6, right? And now we have A that isn't 1, right? So when A isn't 1, you're going to have a number in front of the x. This is going to change things. Okay? Sort of. Okay? This is going to change things. So let's play around with this. Let's use variables and see what we got to do.
Go make plastic day. Hot day.
We'll assume that this guy has a 1 over here for now, okay? So that it splits up into something like we had earlier. Does everybody see that? Okay. And again, I'm using A, B, and C. Don't think of A, B, and C as like the things that we use with standard form. I'm just using variables, okay? Totally fine. So what do we get here? What do we get when we multiply this? What do we get here? ACX, yep. I usually put the x to the end, right? Because these are variables, but they're more like parameters, right? And what do we get here? All right. What does this mean?
It looks really difficult with math.
Notice this. The A doesn't just affect the x squared, right? It also affects this guy. Which guy did it affect? This one. So you have to account for that, right? The two numbers you need now aren't just numbers that multiply to this and add to this, right? They have to add to this after A has affected it. Does that make sense? So you still need B and C to add to your middle guy, but that C is going to get multiplied by A, isn't it? Right? So you have to factor that in. Literally, factor it in. Right? They're factors. All right, so the A is going to affect the C. Now, what if I had another variable here? Let's call it Q. What would it have affected? Well, we'd have a Q here,
It would affect everything.
and we'd have a Q here, wouldn't we?
Yeah.
So you have to factor in the numbers that are here, right? If we're going to go backwards, what we want here and here are numbers that multiply to the end guy. Good. Same as usual, right? Same as usual. But they also have to add to the middle guy after you multiply by the numbers that end up there. That's going to be tricky. So let's try that. Let's try an example where A is not 1. Are there any on here, or are these all A equal 1?
There's on the back.
Okay. Now, all of these on here are factorable, meaning that we don't need the quadratic formula. Could you do it? Oh, sure, right?
Oh, no.
If you really don't like it when A isn't 1, you can use the quadratic formula. It just takes longer, right?
Look it up.
Let's look at number 15. Oh, actually, hold on.
26.
Oh, these are all bad examples. And the reason for that is, look, for 15, can't you just pull out a 2 from everything?
Did you make this paper?
And now A is 1,
Oh.
right? So if you can pull it out, do it, right?
Did you make this paper?
Do that to like almost all of them.
Yeah, you can do it for all of them on here. No, I didn't make this one. I stole it.
Man, you steal all your lunch.
I do for most of algebra. I'm sorry. You guys are really on the back burner. Geometry gets premium. Next year's algebra, my goal is to make them as good as my geometry classes. But I have one algebra class and I have way more geometry classes. So I'm sorry you guys end up in the back burner. I still think you get a pretty good education from me if you're paying attention, though. All right, so
Maybe.
ignore this. And isn't this a problem we know how to solve?
Yeah.
Numbers that add to 3 and multiply to negative 54.
Problematic.
Right? And then we throw a 2 in the end. So what numbers multiply to negative 54? Well, we have 1, 2. Does 3 go into 54?
No. Well, yeah.
Yeah, it does, doesn't it? Does 4?
No.
Does 2 go into it twice? No, then 4 doesn't go into it, right? So 5? What about 6? It does. It's 6 short of 60, right? What about 7? That's a weird one. No, it doesn't. What about 8? No. 9? Yes, it does. 10, 11, 12, 13, 14, 15. Right, let's figure these out. We had 1 and 54, right? We had 2 and 27. 3 and what goes into 54? 3 and what?
Is it 12? 18. 12.
17.
Oh,
Hold on. Is it 17?
it's 18.
No, it's not.
It's 18.
It's 18. Thank you. Thank you.
He wasn't even thinking. He was just-
6 and 9. Already got it. Right. We're good. Nice.
Get it?
Nice. All right. So those are all the factors. Which ones are going to add to 3? Remember, these can be positive or negative. Ooh, actually,
1 and 2.
we need negative 54. If both numbers are positive, will they multiply to a negative?
No.
If both numbers are negative, will they multiply to a negative?
No.
So we know one of these guys must be positive and one of them must be negative. Now, which ones are going to add to 3 when you do that? Which numbers are separated by 3 here? Well, 3 and 6 are separated by 3, but do they multiply to 54?
No.
No, they're not a pair. 6 and 9 are separated by 3 and multiply to 54.
Like negative
Now, which one's going to be negative, which one's going to be positive?
6 negative.
Positive 9, negative 6. They add to regular 3, right?
Don't move.
We cool with that? So when you can pull out a 2, it makes your job a lot easier, right? Just ignore the 2, do the problem as normal, right? But what happens when you can't pull out a number like that?
It'll be difficult.
Stick her back in.
Now, I have defined a polynomial that's factorable, so I'm going to make one up. I'm going to work backwards to give you a problem, okay? So hold on a second. Let's talk about when you can't pull out a number, right?
I don't know. He doesn't know.
All right.
Is this or no? Is this for you?
Here's your problem. Sorry, the 2 got cut off. can you pull out a 2 from everything?
Yes.
No, not even the first thing, right? We can't even group it like we did for completing the square, right? Just pull out the first 2. So the 2's stuck. Now,
Yeah.
if it's factorable, that 2 is going to be split across these 2 x's. And they're going to multiply to 2x squared, right? So if I had 1x squared and 1x squared, does that give me 2x squared when I multiply? No.
Safe start.
What numbers multiply to 2?
1.
2 and 1. Now, does it matter which way I put them? A 1 there, a 2 there, a 2 there, 1. It's multiplication, right? So let's put a 2 here and a 1 there. I won't put anything. Okay? We need numbers that still multiply to -3, right? Because these guys are going to make -3. Doesn't matter what this is, right? They don't touch. These guys do, right? So what are my factors of -3? I'll list them out like this. How about -1 and +3? +1 and -3. This might be a better way to list them out.
That's it.
Any others?
No.
That's it. Unless it's not factorable, right? And then we'd have more. But yeah. So those are our options. We need ones that add to 5. Do any of those add to 5? No. But isn't that 2 going to double this guy first?
Yes.
So we need numbers that when you double one of them and add the other just straight up, they add to 5.
So it's 3x.
Now this is tricky.
But 3.
Let's check them. If I put a 3 here and a -1 here, I get 6, right, from that, -1. That's 5. So that's what works. If I flip-flop those, I get this. Now it's going to be -2 plus 3. That's not 5, right? So order matters, right? And the sign matters too. If I had a -3 and a +1 there, I get -6 plus 1. That's -5, right? So it's a little bit more of a puzzle, but it's doable. You just have to remember to factor in that too. What number is it going to hit? This guy. So know that this guy gets doubled before you add it, right? Are we cool with that? That's weird, but it's doable. Let's do another example. I got to make one up. Let's make one up together. Give me a number to put in front of x. 2.
Come on.
Give me another number to put in front of x. Let's make it not 1.
7.
Let's keep it simpler. Let's do 3.
Oh. We gotta make
Give me a number to put here.
7.
Give me a number to put here.
6.
We'll do 3.
Oh.
We don't want to get too big too fast, right? So here's our problem, right? Let's figure out what that problem even is. That'll be 6x squared, right?
Yeah.
What's this going to make?
6.
6x minus 21x. What's that going to make?
12.
Minus
11.
positive 6x minus 21x. What's negative 21 plus 6?
17.
Negative 15. And that's minus 21. So here's our problem, right? Here's our problem. And we're going to find out that that's the factorization. Is that cool? All right. So I'm going to write this down. Actually, I'll just street it up. How about that? All right. How do we solve a problem like Maria? Now, before, we had to ask what numbers multiply to this guy, right? Now, we've got options. It's not just 1 and 2 anymore. What are the factors of 6? 1 and 6, and negative 1 and 6, right? I'm going to do plus or minus on the side, right?
2 and 3.
2 and 3. So luckily, we don't have a ton,
Negative.
right? So we could either have something where it's x and 6x, or we could have something with 2x and 3x. Those are our options, right? That's a lot of options. We need numbers that multiply to negative 21.
Oh, you got 3 and 7.
We've got a lot. 1 and 21. One of those positive, one of them negative, right?
3 and
3 and 7. One of them positive, one of them negative. So that's lots of combinations. Remember, don't forget about the plus minus, right?
That's 1.
Now, which one of these numbers, after you multiply one of them by 2 and multiply one of them by 3, will add to negative 15?
Don't you need 1 plus 1 and minus?
That's tough. Well, one's going to be positive, one's going to be negative, right? The question is, where does the plus and minus go, right?
I have no idea.
This is a harder problem to solve. So we want two numbers that after multiplying by 2 and multiplying by 3, they get up to 15. So here's what I'm going to do. I'm going to rewrite these guys.
The negative goes first.
Right? If I multiply this one by 2 and this one by 3, I get 2 and 63. Right? If I flip-flop them, and I multiply this one by 2 and this one by 3, I get 3 and 42. Will either of those, when I put them together, if a plus or minus anywhere, am I ever going to get negative 15? No. If that's negative 63 and add 2, do I get negative 15? If it's negative 2 and add 63, do I get 15? No, right? What I did, Ann, is I checked these guys. That's the regular ones, right? I know those guys are going to get affected by a 2 and by a 3. So I'm seeing what those become. Right? And then see what happens, right? Let's check 3 and 7. If I multiply the 3 by 2 and the 7 by 3, I get 6 and 21. Ooh. That's a possibility, right? Now, one of these has to be negative and one of them has to be positive. Which one do we want to be negative and which one do we want to be positive?
21 has to be positive.
Negative, so it's negative 15, right? And we found a combination that works. The minus 21 we multiplied by 3, right, to get there? So it's going to go over here because these two interact, right? And then these two interact. And that'll be the answer. I'm sorry, not negative 21. Sorry, my bad. What did we get? Sorry, I almost had you guys. What did we multiply what did we multiply by 3 to get negative 21? The 7, right? So that'll go there, right? And what did we multiply the 6 by? Or what did we multiply the 2 by to get? God.
6.
The 2 and the 3 get us a 6, right? So the 3 is going to have to go here. 2 times 3 gets us the 6. Negative 3 and 7. Or negative 7 and 3 gets us negative 21. So that's the correct combo. It's a lot of guessing and checking and figuring stuff out. Here's my advice. If you can't get this, if you've got multiple combinations here, use the quadratic formula. Right? It's a pain in the ass to memorize, but it's easier than guessing and checking all this. Imagine if we had more guys to check over here. And we didn't even check 1 and 6 because we cheated. We knew it was 2 and 3, right? See what I'm saying? Now, I'm going to show you a way that's going to simplify that work for you. But for now, if it's too complex, use quadratic formula. Call it a day, right? Okay. Use quadratic formula.
Yeah.
Cool? All right. Let's try one more. Let's make a problem up. Somebody other than Shambog, give me numbers this time.
Me.
42.
12.
Give me a number to put in front of the X. I swear to God, Mitchell.
3.
6.
7.
6 and 9.
Give me a prime number, a small prime number.
7.
89.
6 and 9.
Give me a small number to put in front of X.
3.
You guys are digging your own graves. What numbers do you want to put here? Small.
75.
Minus 2 and
7.
Someone's about to get shanked, I swear.
7.5.
all right.
He's gonna shank us. What you gonna do about it?
That's the answer, right? Let's figure out what the problem is. That's 21x squared. What's this going to be?
There's a bomb.
7x minus what?
6.
6x.
Negative 6.
So 1x.
It's actually negative 6.
7x minus 6x, 1x. What's this going to be?
2.
That's the problem. This is the answer. Let's see if we can work backwards. First of all, let's figure out our factors of a, right?
7. 3.
1 and 21,
3 and 7.
both positive or both negative, right? 3 and 7, both positive or both negative, right?
7 and 3.
So our options are x and 21x and 3x and 7x. Doesn't matter what order we put them in because it's multiplication, right? Now, we need numbers that multiply to negative 2. Give me numbers that multiply to negative 2.
Negative 1.
1 and 2.
Negative 1 and 2, 1 and negative 2, and that's it, right?
2. Negative 1. 3.
Now, after I apply these,
Yes.
let's multiply by 3 And let's multiply by the 7. What happens? That becomes what? Negative 3. And this becomes 14. This becomes, and this becomes negative 14. I want numbers, sorry, get rid of these. I want numbers that add to 1 after being multiplied. Do either of those add to 1? No. So it must not be 3 and 7. Wait, it was 3 and 7. What do we do here?
Messed up. This is impossible.
We did. We're just going to call it for today. That's the idea. Okay? We want to figure out what these numbers are. We're going to try to get them together.
This is an impossible one.
Oh, sorry. No, we didn't. No, we didn't. We're good. We're good. We're good. I'm getting brain fart again.
What's happening?
All right. We're good. We're good. So, we're good. We know the answer is -1 and +3, right? Or -2 and +1.
Yes.
So there should be a -2 there and a +1 there. So neither of those work. What if we times by 7 and times by 3? Times this side by 7. What do we get?
Negative 14.
-7. What's this times 3? What's this times 7?
7, -7.
+7. What's this? Do any of those, when we combine them by adding, do they get me 1?
Yes.
Yes, 7 and 6. The 7 needs to be multiplied, or the 1 needed to be multiplied by 7, right? So I'm going to put the 1 here. And the -2 needed to be multiplied by 3, right? So I'm going to put the -2 here. Because these multiply and these multiply. And that's the answer. There's an easier way to simplify this, and I'll show you that later. But I want you to see the logic behind it first. Okay? It's kind of confusing because you're like, I need these numbers, and none of those numbers work. Well, we forgot to do it the other way, right? And then I'll put 7 and 6 in here. Oh, that doesn't work. No, you have to do it before they're multiplied, right? That's a pain. How do you feel about when A is 1? Great. When A is not, more difficult, right? If you can, but what if you can pull out A from everything, right? Oh, golden, golden. But if you can't, we'll get used to this tomorrow. And again, worst case scenario, quadratic formula, right?
Yes.
What if you forgot the quadratic formula?
Then you are a
Derive, right?
You're a melon. Yeah. I remember that. I remember that.
Right?
I don't.
Derive if you forget it.
I don't remember that. Wait, you do? No, I don't. Hey, Mac. I don't pass.
Are you talking to me? Yes.
10-4. 10-4 would be good.
I would practice deriving the quadratic formula.
Hey, Mr. Mac, you want to catch this?
No.
I just got to throw it up there.
No, you're not.
Where am I going to hold it up and throw it to me? One more? Maybe one more?
What about Maverick?
Okay, are you going to be here tomorrow morning? Like,
I will.
so I can take that test, probably. No. Whoa. You had your one shot. Your one opportunity.
If you just had one shot.
Denise Ruetti spaghetti is that Farmer, that was sweater already. Mom, spaghetti. That got mess over her head here. Mom is doing weird. What? Ice. Where do you see where's my tractor? Where's my tractor? Oh.
Wait a minute. Get it? It's such a good, yeah, it's such a good vibe.
Such a neat song. So
I'm taking you back. Wait a minute, I don't know if you can put it back in.
These weak bones, I hate you for right.
Take me for a ride on your big truck.
Make sure you can come up with the quadratic formula. Worst case scenario. Quiz will be on Friday over this stuff. It's going to be when a equals 1, when a is not equal to 1 but is factorable out, right? When you can pull it out. And when a is not nice, right? Worst case scenario, quadratic formula. No, I will not be giving you a note card.
Why not?
Because you need to know quadratic formula. If you don't know the formula, derive it. If you don't know how to derive it, well then we have a problem.
I know the formula.
Why do you have me?
You're working this so far straight.
That's why they.
I don't want to sound like it. I can have you guys sit
That's
Your nipple? Your uncle did?
That's what I said. You.
Aaron, gotta look at it. Gotta look at it beautifully.
No, you meant Jason.
No, you and Jason have the same.
No.
Hey, Josh.
Bring.
No.
Your brother?
What do you mean, brother? You both got glasses.
And you guys both wearing the same color.
Same shirt.
Same.
Oh my god.
I'm not going sexual.
That's a good song to vibe to. How do you milk the pigeon?
Well, you're
Focus your new glasses.
Are you hearing this, Mr. Rat?
Everybody sit back down. We have a little bit of time, right?
How do you milk a pigeon?
How do you milk a pigeon?
Sit down. I'm going to try a singing arrangement thing. Come on, hurry up, hurry up.
I really hope I can still have it.
Whoa. You can sit on your desk instead of sitting in it. That's fine.
I'll sit on Preston's. Sit on Preston's face.
Sorry. No.
Even Samba?
Stop.
It's all.
Put all your weight on this.
I know.
I'm sorry, I won't touch you.
I know.
How does he fit 3 more cups? Oh, it is like he's over top. Everything over top, and like healthiest like squeeze. Does it hurt? Like if the desk like does like a lot?
You got the same shirt on.
My favorite. I'll go back to
He is your brother. Stop denying.
I think me.
How was baseball?
No.
Did you go to it? Huh? Were you able to practice? Did you get some break some windows? Why? Why do I have to move back?
I want to ship.
Me and Josh that we want to swap seats.
And move Jace over here.
Yeah, I like you.
All right.
Warriors and odds.
I'm doing
You two stand up.
I'm doing.
You two sit here and here. What are you talking about? Jordan on this side. How about me? Mitchell. Grab this spot.
I'm doing my squats.
Mouth
I would kill you.
Lindsay.
Hey.
Mean about what? Fruit Loops. Lindsay, would you prefer here or would you prefer
Doing
there?
squats.
There? Alright, then and you're here. Fruit Loops.
I guess you'll show you a
I
picture.
get to buy some Fruit Loops.
Him?
Here it is. Him, yeah. Favorite.
Yo, let's see, we do.
Well, guess
Put me up.
what?
I should have.
Stand boss, which was Mitchell.
What? I was gonna chill. Stop. I don't want to sit by my.
He has to get to sit by my dog, Mitchell.
Hugger.
You wanna go check, bro?
How am I mean?
Hey, Josh said he's gonna
I'm not
teach
mean
you.
if I don't want a relationship.
Say that.
Then what is it about? Snapchat it to me.
That is the face of pure concentration.
Hey, I think we should
You
move
really?
Mitchell away so we can cheat on my test.
Matt, can I do a pass quick?
Not yet. I'll give you that.
Try a week.
Josh, why do you hate me? I've done nothing but been nice to you. Notice you have not moved. Can you and Mitchell switch?
No.
Mitchell, how do you feel about this spot?
Yeah.
Yeah.
No.
Me and Mitchell should switch.
Be gone.
I am going to do bad.
I want those seats tomorrow. Try them out.
I am going to finish my even harder.
Why?
my dolls.
Is that an issue? We need to take care of ourselves instead of relying on you to take care of us. How about that?
Yeah, our test is Friday.
Okay.
Alright,
Yeah.
get you, I think.
The worksheet that we did, I'm gonna have to come in and do a little bit.
That's fair.
Not today, but
That's fair.
I'll do it tomorrow.
Whatever. Here you go.
Thank you, man.
Mm-hmm.
Yeah. Are we not sitting on the floor to be a distraction?
No, you were totally fine.
Annoying.
And I know you're good.